So we've seen before as a class that if your function is constant, then you know the derivative is 0. We've hammered that point. And you might at some point ask if the other direction is true. If you know the derivative is 0 on an interval, is that enough to know that the function is constant on the interval? And the answer is yes. So I've called this a proposition. A proposition is like a theorem. It's just a fact, a mathematical fact. And then as a corollary, and this is really the key corollary for us, and so I'll do an example with you. But if two functions, different functions, but if they have the same derivative, so f prime equals g prime, same derivative on an interval, then how different can the functions be? And the answer is not very. If their derivatives are the same, they only differ by a constant. One function equals the other function plus, I've written plus, the c could be negative, so it could be minus, plus or minus a constant. And I guess I should add here on the interval AB. So let's do an example with this. So I want to find all functions h of x such that h prime looks like that. And so I'm going backwards now. This is kind of weird. We're going to do this a lot in the next section, but I'm going backwards. And so I'm going to think about the power rule. And if I were going to take the derivative of x cubed, I'd get 3x squared. I want to go the other way. I need a function whose derivative is x cubed. So how about h of x equals x to the fourth? If I take the derivative of x to the fourth, there's a 4 sitting there. I don't want that, so I'm going to divide by it. Plus x squared plus x. Now let's check. Do we agree that the derivative of this is that? Well, yeah, I do. So that's the derivative. And then there's just that what the corollary is telling you is, okay, any function whose derivative is this h prime that we want is going to look like this plus some other constant. So we'll just put a plus c, and here c is any real number you want. So there's actually infinitely many functions. Let me give you some examples. So one would be h of x equals x to the fourth over 4 plus x squared plus x plus 0. Another might be, let's copy this. I'll call this one h2. And instead of adding 0, I'm going to add pi. And another one might be, well, I want to add, I don't know, let's subtract 71. And so on and so forth. So you can pick any constant you want. The point is this. If your derivative looks like x cubed plus 2x plus 1, if that's what your derivative is, then you are this function plus or minus some number. That's it. That's the only options. And that's what this corollary is saying. So we'll explore this more in the next section, but I wanted to go ahead and mention it now. So you've got everything you need to do homework number 22 over section 4.2.